Hello everyone, this video is about logarithmic functions and the basics of logarithms. Let's start with exponential functions first. We know that if there is an exponential equation like 2 to the x equals, let's say, 8, you can do the mental math and guess what x is, what the exponent is. What is the number that we raise 2 to get 8? That's 3. But if your number is something like 2 to the x equals 3, you can't know what your x is. You can't do the mental math here. So in this case, we need to isolate x. We have a way of isolating x. By using logs, we will be able to find x. So how do I write this exponential equation to get x by itself, to isolate x? So that's the question. So in this section, we will be learning how to convert exponential equations to logarithmic equations. So let's say our exponential equation is b to the x equals a. That's the basic form of exponential equations. B raised to power x equals a. In order to convert this exponential equation to logarithm, we are going to put x, the exponent, on one side of equation because log means exponent. So x is an exponent that I have to raise b to in order to get a. X is the exponent that I have to raise b to in order to get a. So I will put x on one side of equation first and write log and use the same base as I did in the exponential equation. Use b as a base. In logarithms, we write base as subscript. So log subscript b, log base b of a, the number on the other side of equation, equals the exponent. So we can do this conversion back and forth. We can convert exponential equations to logarithms to exponential equations. For example, 3 to the power of 2 equals 9. You start with the base, you keep the same base, go to the other side of equation, and come back for the exponent. So log base 3, write 3 as subscript. This is the same base that I used here, of 9 equals the exponent. So exponent is always written on one side of equation. The others are on the other side. The base is with subscript log, and the other number that the power equals to, is written right beside log. Log base 3 of 9 equals 2. And we can do this conversion in the other way around. So when you convert it to exponents, you start with the base again, go to the other side, and come back. So 3 to the power of 2 equals 9. 3 to the power of 2 equals 9. So that's how to convert logarithms to exponents, exponents to logarithms. So let's continue and solve some examples and see how to convert them to each other. The first question, write each exponential equation in logarithmic form. Start with the base. Base is 9. We're going to use the same base as subscript. Go to the other side of equation and come back for exponent. So it's going to be log base 9. 9 is the base, can be written as subscript, of the other side, 81. Write 81 right beside log, not as an exponent. It must be written in the same level as log, equals the exponent, which is 2. Similarly, start with 3. You follow this order. Log base 3 subscript of 27 right next to log equals, come back, use the exponent on the other side of equation. Same idea, it doesn't matter whether we have numbers or letters or variables, we do the same. Log base X is the exponent, keep the exponent as subscript, of 1, write 1 right beside log, equals, come back for the exponent, 0. And that's it. Same idea, we can change the statements. So they are equivalent. Those two statements are all equivalent to each other. So this is the log version of this exponential equation. So those two are identical. Similarly, you can do the opposite. You can convert logarithms to exponents by using the same order. Here I have 10 as a base. I'm going to start with the base, go to the other side of equation and come back. You follow this order. Start with the base, keep the base, same base. 10 is our base. Go to the other side. 10 is raised to power 1 equals, come back, 10. 10 to the power of 1 is 10. Similarly, 12, go to the other side, 2, come back, 144. So start with the base, which is 12, raise 12 to 2, equalize it to 144. Start with the base, which is 1 over 2, 1 over 2 raised to power negative 3, equals, come back, 8. But here the thing is, we should be careful about this exponent. We have an exponent and there is a fraction here. The fraction is raised to power negative 3. Not only 1, but also 2. So I have to make sure I'm using bracket around. So whenever I have fractions raised to any power, I have to use the bracket. So that's pretty simple. This is how you do the conversion. And now we are going to learn two of the properties that we are going to use in the following sections. Log base b of b is equal to 1 because when you do the conversion, b to the power of 1 equals b. b to the power of 1 equals b. So we have log base b of b equals 1. So whenever the base and the number written right beside log are the same, they are same numbers, then the result is turned out to be 1. Similarly, log base b of 1 equals 0. When you do the conversion, b to the power of 0 equals 1. b raised to power 0 is 1. Any number raised to power 0 is 1. So you can say whenever there is 1 right next to log, the result will turn out to be 0. Log base b of b is always 1. Log base b of 1 is always 0. For example, log base 10 of 10 is 1. Those numbers are equal, so the result is 1. Log base 10 of 1 is 0. There is 1 written right next to log, no matter what the base is. Since there is 1 written right next to log, it's going to be 0. So those two properties are important for the following section, and we will also be using them in graphings. And one last thing about logarithms, some calculators have only this button. There is no base button in the calculator. So what does it mean? Does it mean that we don't have a base? Is that possible that logarithm has no base? Is it possible that the exponential equations have no base? It is not possible. Every exponential equation has a base. Every logarithm has a base. But there is a logarithm called common logarithm that has the base 10. So if there is the base 10, we don't have to write 10. There is an invisible 10. So writing logarithm as log 5 is same as log base 10 of 5. So generally, most of the time, we don't see 10 written as a base. So whenever base is invisible, we will know that the base is 10. So such logarithms are called common logarithm.